If the water were drained from all the oceans, a stunning feature would become evident: a 65,000 kilometer long mountain range encircling the planet like a seam on a baseball. These are mid-ocean ridges, the points where the continental plates are pulling away from each other. As they stretch and weaken, the gap between the plates fills with new volcanic crust drawn from the Earth's magma. At depths of 7,500 feet, or 2,300 meters, pressures of depth force seawater into cracks where it contacts the magma of the Earth and is returned as a fantastic, uninterrupted geyser of superheated fluid at temperatures as high as 400 degrees Celsius or 750 Fahrenheit, hot enough to melt lead. The Marshall Hydrothermal Recovery System is the first vehicle in all the patent literature to make possible commercial electricity generation from hydrothermal vents. The system uses a prefabricated conical base that is lowered over one or several vents. Highly insulated pipe segments with buoyancy collars attached to increase vertical stability and reduce cumulative weight are stacked on top of each other until a continuous pipe is constructed from the vent to the surface. An oil platform located above the vents holds the generators that will be driven by steam derived from the captured energy, and undersea cables would carry the power to a nearby shore. If the hydrothermal fluid is brought directly to the surface, a fantastic mineral cocktail comes along, making the Marshall system the first practical deep ocean mining system, and the steam derived can be distilled back into fresh water, which would also make it the most energy-efficient water desalination system ever devised. If energy is the only desired end product, a closed-loop system can be used instead, which would use the hydrothermal energy to heat a clean working fluid for direct use with steam turbines. Hydrothermal vents are the single most powerful energy source ever to be harnessed by mankind, eclipsing even nuclear technology. While the largest nuclear plant in the U.S. can power about 4 million homes, one Marshall system plant using a single 3-meter pipe could power 20 million homes. Hydrothermal vents are located near many energy-hungry areas of the world. They are known to be just off the coasts of China, Japan, and Korea. They run through the Mediterranean Sea, traverse the Red Sea in the Middle East, and are found near the coast of South America. The Juan de Fuca Ridge, just 200 miles from Seattle, has a main active vent field that is about 180 meters wide and 350 meters long. Within that field are more than 15 large actively venting structures, up to 30 meters in diameter and greater than 20 meters in height. Even with all that is known about hydrothermal vents, there are still tens of thousands of kilometers of ocean where vents should be located that have never even been explored. Hydrothermal energy is the holy grail of renewables. All other sources, such as solar and wind power, are subject to obvious natural fluctuations and have low energy density. While important, they require a lot of real estate to generate enough power to make a difference. The intensely focused energy from hydrothermal vents assures that it will play a huge role in meeting the energy needs of the future. The U.S., Canada, China, Japan, Korea, Europe, the Middle East, North Africa, South America, and India are all within reach of hydrothermal systems. Hydrothermal vents can provide up to 5 times more power than nuclear plants. No greenhouse gases, no external fuel is needed, nothing is burned. Hydrothermal vents are not subject to the natural fluctuations that hydroelectric, wind, or solar systems are subject to.